Okay, standard integration results with other functions. So you've already met the differentials of these. E to the x, we know it differentiates to itself, so it makes sense it integrates to itself as well. On all of these, we're getting a plus c from the constant of integration. The sine and the cos, they're a bit awkward with the minus signs. So sine goes to minus cos goes to sine, again with plus c's around. Instead of remembering them as a table like this, if you think back to the wheel we drew for the differentiation, this is the wheel for the differentiation. So sine goes to cos goes to minus sine goes to minus cos goes to sine. This is differentiating. Instead, if we integrate, we're just going the other way around the circle. Usually in the exam, it's a good idea to draw the differential one and then just think, okay, we're going the opposite way around. And we're picking up some plus c's along the way. Cool. And then the last one, we know that log x differentiated to 1 over x. So going the other way, 1 over x has to integrate to log x plus c. At the moment you haven't met modulus signs. It just means making the thing inside positive. Don't worry about it too much for now. Let's do an example with one of these using integration by substitution. So if we had the integral of, let's do sine of 2x dx. Well, a good thing to choose as your substitution here is u equals the thing in the middle. Like if I put some brackets around, we don't really need them. It makes it more obvious what we're picking as the substitution. So u equals 2x, du dx equals 2, and so dx equals du over 2. Pushing that into this, our integral is sine of u, and then dx is du over 2, so it's du over 2. Now, I can put it wherever I want, under here. I'm just going to take out the factor of a half at the beginning. Doesn't matter where we put it. Okay, sine u, well, thinking back to our thing over here, sine integrates to minus cos. So, equals, we've still got the half. There we go, from there. Sine goes to minus cos, so I'll bring the minus out the beginning, and we have cos u plus c. And then we could pop that back in. So we have equals minus a half cos of 2x plus c. Cool. Here's one for you to have a go at. Have a go at e to the 2x. Right. Pause the video and have a go. Right, so once again, I'm going to pick u equals the bit inside the function. So u equals 2x. Differentiating it up and doing the rearranging, we get dx is du over 2. This thing here is the integral of e to the u du over 2. I'm going to bring it out again. I'm just bringing it out because it gets less messy. If it's inside, it starts interacting with stuff. Whereas out here, I don't have to worry about it again. So it equals a half, e to u goes to itself, plus c. And then that's a half e, and then putting that back in to the 2x plus c. Done. Notice here, with differentiation, usually we're timesing down by the power. With integration, we're usually dividing by the power. So we had this thing up here, the 2. The differential of this thing is 2. So we ended up dividing by it. Similarly on this one, where we had a 2 in here, we end up dividing by 2. Do shortcuts. Cool.